Hello and welcome to joint Buffalo State and UB Smart Grid Lab. This lab was funded by the Department of Energy grant as part of the America Recovery and Reinvestment Act. Our institutions are part of the larger consortium consisting of Syracuse University, Clarkson University, University of Rochester, and Onondaga Community College, and of course, University at Buffalo and Buffalo State. Let me demonstrate what our lab can do. My name is Dr. Ilya Grinberg. I'm the project director at Buffalo State.
I'm Mohammed Safiuddin. I'm the research professor at University of Buffalo, and I'm the co-director for this Smart Grid Lab.
And we want to introduce you the components of this lab. As you can see, here is a solar panel. We can adjust the light for the solar panel. You can adjust the direction of the sun.
From sunrise to sunset.
And you can adjust the elevation.
Or the elevation from winter to summer seasons. So students can adjust whatever condition they're trying to experiment with.
This set allows advanced photovoltaic studies. Few more modules here. This is another solar set that allows emulation of different conditions and shading. As you can see, it is on right now, and with different modes, you can see the amount of power that this set can generate. The solar set is connected to the grid through the network inverter. So this is the network inverter. The utility connection to the system is introduced through a switch. Now, as you can see, we have power from the utility that comes through the circuit breaker to the transmission line. The transmission line represents two possible models. Medium length transmission line, about 90 miles long. This is what you can see now. If we remove the overlay mask, you can see the transmission line with a length of about 190 miles. And the parameters of these lines, of these two models, actually change automatically and change the behavior of the system. The system is equipped with smart meters. You can see smart meters right now. They are all fully programmable, and they have long-term memory. One of the features of these meters is that they have TCP/IP connection, so they act as sensors. The next element in the system is an overcurrent relay. This relay is also TCP/IP enabled. Then the next is the circuit breaker. And one of the most important features of the system is a double bus bar system. As you can see right here, you can reconfigure it based on the conditions of the operations, and each load and each source has its own section. All the units here are also internet enabled. The system is controlled with a supervisory control and data acquisition system. You can see it right here on the big screen. And let me demonstrate the capability of the system. Computer-based supervisory control and data acquisition system is an integral part of this set. As you can see here, the green indicators are showing that the breakers are closed. The red indicator shows that the breakers are open, so we can reconfigure things. So for example, right now the power is coming from the utility to the bus bar, from the solar power plant to the bus bar, and then we have several consumers connected to these buses. Let's say here is an industrial plant and we want to launch this plant. We just press this button and the motor starts running. The motor emulates the industrial plant, and you can see the change in the voltage levels from 136 to 112 volts which is very important to observe. We can stop this load, and you can see that the voltage levels go up significantly higher. We can also engage another load and watch the change in voltages as the load increases. And now we decrease the load, the voltages change as well. Another important feature of this system is that we can observe the change, the daily variation curve of the load. For example, let's start this motor again, and we will start recording. You can watch the consumption, and now we engage the load. The consumption goes up. Now we increase the load. And the consumption goes up. We decrease the load, the consumption goes down. Increasing it again. The main feature of this lab is that it is used for experimental part of undergraduate education, as well as for research component of graduate education, such as on the master's and doctoral level. And we have a doctoral candidate from the University of Buffalo, Ramadan El-Moody, who is working in this lab on his experimental part of his doctoral dissertation.
Hello, this is Ramadan El-Moody. I'm a PhD candidate from Department of Electrical Engineering at UB. As Professor Greenberg said, the best feature of this lab, it can handle the fundamentals of electrical engineering until the highest point of doing a research, as I'm doing now in this lab. I'm trying to make the smart controllers more efficient and to optimize the smart controllers for what you utilize in the smart grid.